neutron stars. Now they were main sequence stars. They were generating an outward force. In the inside, hydrogen was pressed together, forming helium, and during that there was an outward force. So the big force for the gravitation falling on itself together, having so much gravitational force that it falls on itself together, was halted basically because there was an outward force. Then the subgiant phase came after the main sequence phase of a star or sun, and where the core is contracting even more, but there's still coming something from the outside in, and when the hydrogen from the outside comes in together, there it expands again, the core is shrinking, the outside is shrinking, but then because hydrogen is pressed together, because it comes closer to the center, it's expanding again, the core is shrinking, the outside is expanding. Now we're having the next phase, the giant phase. Now the core has shrunk more and more together until it got 100 million degrees Celsius, and now the ash of a hydrogen production, previously hydrogen pressing together to get helium, is able to fuse again. So now by 100 million degrees, 10 were necessary for hydrogen, 100 million degrees, helium is crushed together, new outward force. It blows away this outward expanded subgiant thing which has expanded into a planetary nebula thing, and it blows it away and becomes a white dwarf. It blows basically away what it has, all is burned up, and the center is just shrinking more and more and more. It becomes a white dwarf. No light anymore, no heat, it cools down over hundreds of millions of years, and then it's just a thing. Neutron stars are heavier than normal suns. Normal suns are becoming then just a white dwarf. The electrons are completely standing together, and they have a degeneracy, these gases degeneracy, and they're no longer falling together. All these electrons are standing together with their shells, these atoms with their shells with the electrons together. Completely pressed together, that's a white dwarf. Nothing happens anymore. If its sun was bigger, the whole thing was way bigger, and the pressure on these electron shells, was much bigger, because the star is much bigger, and now they shatter. And the electrons on the outside of these shells and the protons inside of a nucleus of such an atom are fusing together. They are pressed together and forming new neutrons. The electrons on the outside of the shells and the protons of a nuclei form together, becoming new neutrons. And the whole thing exists out of neutrons. And now, when we were pressing together like that, they're getting much smaller. A normal star gets already down to Earth size, much compressed. But now they're going down to just a few kilometers, which is kilometers big, but they were massive. And now they're just very, very, very small together. And if someone is spinning and turning around and puts their arm in a figure skater on ice, they're turning faster. Or basically, if there's a long outward force and that's brought in, now that same speed is there, but on a much smaller space. I think that is the explanation for it. So basically, all this outward force, which was turning normally in such a big sun, is now very much close together. And now the whole thing is spinning very fast. The Earth is turning around in one day around its axis. Such a neutron star can spin hundreds of times a second. So incredibly fast. And it can have very strong magnetic fields along its axis, and they can be pushed out when along its axis, and better than pulsars. So these super amplified magnetic fields can be pushed out along the axis while it is spinning, so hundreds of times per second can be pushed out, and that is known as pulsars. And that is according to Mark A. Garlick's Cosmic Theory book on the page 51.